Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean, and I'm delighted you're joining us for today's ESPC community webinar. Today I'm joined by Alan Canan, MVP, who will cover Azure networking, an essential skill for cloud architects and IT professionals. We love hearing what you guys have to say, so remember to join in on the conversation about today's webinar and more on X. Our handle is at ESPC_community, and our hashtag is hashtag ESPC24. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated daily with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking the Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Common Business Challenges that Microsoft Fabric can Address, with Clive Lemon. This webinar takes place Thursday, the 8th of August, 2024, at 11 a.m. to 12 p.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Join us for an exclusive opportunity at hashtag FabConEurope with our super early bird sale. Act now and secure a ticket before Friday, July 31st to unlock incredible savings of up to €700. Don't delay, register today to reserve your place and take advantage of this limited time offer. Book your tickets today at www.sharepointeurope.com/European Microsoft Fabric Community Conference. Early bird sale alert for hashtag ESPC24. Deep dive into the latest in governance, Azure, SharePoint, Copilot, Microsoft Teams, Viva Topics, API, AI, Microsoft Entra, Power Automate, Microsoft Purview, and more. Don't miss out. Register your interest today at www.sharepointeurope.com/pricing. After this webinar, we'll have a questions and answers session. Type any questions you might have into the questions box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now, I'm going to pass you over to today's webinar presenter, Alan. Hello, Alan. Thanks for joining us today.
Thank you very much indeed. Great to be here. Great to speak with ESPC conference once again this year. Let me just get my presentation shared.
Yeah, I can see your presentation there.
You can see that. Perfect. Okay, let's get started then. Thank you very much for joining the session this morning. Very interesting day in the IT world. Today, no doubt most of you have heard that major IT outages due to an issue with CrowdStrike. So I really hope and feel for everyone who might be affected by that. It sounds like it's going to be a tough few days ahead for several people. That's the world we live in these days. My session today is all about Azure networking. Azure networking is a very broad topic. There's a huge amount we could cover, but we only have an hour today. So I'm going to cover some of the essentials, and I want to talk about why Azure networking is an essential skill for anyone who's doing cloud architecture or anyone who is an IT professional these days. And even if you've never worked in cloud before, chances are you're moving into that, you're transitioning into a cloud-based role. Azure networking is going to be very crucial as a skill set to you, no matter what you're doing in Azure. So that's the core topic of my session today. A little bit of an introduction to myself. So my name is Alan Canan. I am a Microsoft MVP. I'm in the Microsoft Azure category, and I'm also in the security category. I'm in the program. I'm in my third year now at this stage. It's a really great program to be involved in. I really get a lot from it. I'm also a Microsoft certified trainer, and I hold multiple Microsoft certifications. Predominantly, I work in the infrastructure space. My role is an Azure infrastructure practice lead, working for a Microsoft partner based in Dublin, Ireland. So predominantly I do work with infrastructure, which traditionally would be very network heavy, very focused on that. If you're interested in following me, I do have a blog website. It's azurealan.ie, and you can connect with me on LinkedIn and Twitter. Details are on screen there. So what is in store for the session today? Well, like I said, it's all about networking. And you might think, well, networking, isn't that just for virtual machines and servers? I don't need to know about that. I don't work with those technologies. Why? Because I don't do IaaS. I'm not an infrastructure person. I don't need any of that networking stuff. or I'm cloud native. I only go for platform-based services. Again, they don't need networking. Or maybe you say, I'm a developer. I develop code. I like to push it up to the cloud. There's lots of great serverless services up there like Azure Functions. I can just push code straight to. Again, I don't need to know networking. Well, that's not really the case. Networking really is a fundamental skill set if you're working in Azure at all. Believe it or not, everything in Azure runs on servers or on virtual machines. Another MVP told me that all of those platform-based services that Microsoft manage for you, they're all actually running on virtual machines under the hood. The difference there is Microsoft manages those virtual machines for you and they manage the networking side of it for you. But don't be mistaken, everything actually does run on virtual machines. So it is good to understand how they work and how they connect and talk to each other. Networking does apply to every single solution. If you think about it, no matter what you're doing in Azure, you have to in some shape or form connect to that. And that, yes, might be over the public internet, but quite often you might want to have a private connection to that, like VPN connection or express route. But you do have to connect to it, and those services need to talk to each other. So you're going to have connectivity within those resources on Azure. Security, that's paramount these days. We've got a major security related issue today, coincidentally, but again, security is important when it comes to designing your solutions. So private networking is crucial. Probably all heard about zero trust architectures. Private networking is essential to that. It's all about zero trust. You want to make sure you're not trusting anything by default. Everything's being checked and validated every time it's being accessed. And where possible, you should avoid using things like public endpoints and make things private. So platform services can also be private. So if you're not using virtual machines or using some of those platform services available in Azure, and yes, you can access those directly over the internet with a public IP address. Most of those services nowadays can also use something called a private endpoint, which is how you can access that through private networking. And that's, again, a best practice. Where possible, you should try to do that. So really, we want to empower yourself with the knowledge to understand Azure networking. You don't have to know everything about it. It's a very broad and complex subject, but the more you know about it, the better you'll be able to design those solutions, put them together yourself. So my agenda for today, again, we can only cover certain aspects given the time we've got. So I'll talk a bit about virtual networks, because you can't do any networking without having a virtual network. So talk about that and the structure of those and how they all work. Talk a bit about routing, which is, again, something that a lot of people don't understand. We'll just cover some of the basics on that, which is very, very helpful when you want to understand how things connect and talk to each other. Connectivity, there's lots of options there. I'm going to cover a little bit about VPN connectivity because it's by far the most common approach to private networking. If you need to connect your Azure environment to another cloud or maybe an on-premises environment, VPNs would be the most common approach. So I'll talk a little bit about that. Maybe it's something you're not familiar with. Network security, again, we'll touch on some of the options you've got there. It's, again, you could probably do a full day on network security alone and still not cover everything, but we'll cover some of the more common options you should be looking at when you're doing network security. And then how do you troubleshoot? That's important for networking. If something goes wrong, what tools have you got there to help you to resolve them? So we've got Q&A at the end. Please do use the chat box or the comments box to put in your questions. And we should have some time left at the end to field some of those questions. I'll do my best to answer them then at that stage. Right, let's kick off then with virtual networks first of all. So quick intro to virtual networks. Fundamental to many Azure services, again, not just for virtual machines. We need to use virtual networks to connect anything that's using a private endpoint. So any of those platform services that you want to access privately, you will need to create a virtual network to host that private endpoint. It's a regional service, so you have to pick which region your virtual network goes in. So for example, you might deploy a virtual network to the West Europe region, but you can connect to resources in other regions. Okay, so all the resources connected directly to that network need to be in the same region. But if you've got a deployment in, say, West Europe, and maybe you want to connect to resources in a US region, you just create a virtual network in the US, and then those networks can be connected together and they can talk to each other easily enough. We'll talk about how that's achieved later on. And of course, this allows you then to connect your Azure network environment, so anything that you've got connected and deployed in Azure, to other public clouds like AWS or Google Cloud, or to maybe on-premises data centers, which is a very common requirement. So what are the capabilities of virtual networks? Communication, I suppose, first and foremost. You're probably going to need to connect to the internet or something that's hosted on the internet. So they need to be able to talk out from Azure to the internet. They need to communicate to each other. So those services you deploy need to talk to each other quite often, VMs especially, but not just VMs. Again, you might have a VM and a platform-based product that need to talk to each other for various reasons. So the only way they can communicate is through networking. Again, ideally, you want to do that privately and not send all that traffic out over the public internet. You need to filter your traffic. So you want to protect and isolate traffic from one segment of your networks from the other. Not necessarily everything on your network needs to talk to each other. So again, it's a good practice to put in some isolation, to put in some network segregation, so that not every system on your network can talk to everything else on the network. So that can be done as well through design and some network security, which we'll talk about. And you need to route that traffic. So at the moment when you deploy something in an Azure virtual network, it can talk to the internet by default. That might be good. Microsoft are going to be making some changes there to stop that as a default option, but you can still obviously achieve that, and you are in full control of network routing. So if you want to route all of your network traffic through, say, a firewall, you have the options to do that, but you're in control of the routing. We'll cover that in the next segment. So what goes into a virtual network? Well, first of all, you obviously create a virtual network to host a new workload. So whenever you've got a new workload that needs to be connected to a virtual network, as I've mentioned, needs a VNet deployed before you can actually do anything else. So it's a fundamental requirement. It's required for any virtual machine, so you cannot deploy a virtual machine without a virtual network. It has to have a VNet. But as I mentioned, those PaaS services, although they have public endpoints, it's a good practice nowadays to put a private endpoint on those. And a private endpoint effectively gives it a private address, private IP address, which again has a requirement, a prerequisite for a virtual network in place. So in a virtual network, you have to define a network address space, and that needs to have at least one subnet, which is a subdivision of that address space. And you can have multiple subnets. Again, we'll talk about that and why that's a good design practice. And then you want to secure that virtual network. And we've got plenty of services, Azure Bastion, Azure firewalls, you've got DDoS protection, you've got network encryption now as a fairly new option, and you've got network security groups to filter the traffic within that network. We'll talk about some of those in this session today. So I mentioned an address space. You have to define an address space when you're creating a VNet. So there's a common range of address spaces called the RFC 1918 ranges. You'll see those on screen there, and you might be familiar with these already. You might be used to these on premises. These are private address spaces. Okay, so when you're creating a virtual network, you're generally using private address spaces. These are private to you. You can have multiple networks with the same address spaces. They're isolated from each other, but the issue you need to look out for is if you ever need to connect those two virtual networks with the same address spaces, you're going to have a problem because that just won't work. So when you're designing your virtual networks, you want to make sure you don't overlap address spaces. You keep address spaces separate from each other. And that also applies very strongly to your on-premises environments. If you've got, you will have address spaces on premises, you don't want to reuse those in Azure, because if you try to connect those up then later on, you're going to have issues. There are ways to do it, it just gets a little bit more complicated. So ideally, you want to make sure you're always using different address spaces. You have to define a range of addresses. I mean, these can be thousands and thousands of IP addresses per virtual network. You don't need to go crazy and make it massive. Keep it small. That's a good practice, but don't make it too small that you can't grow it over time. You're going to be adding more services to your networks over time. You'll find also Azure takes the first 5 IP addresses from you. They need to use it. Azure needs to take 5 IP addresses for routing, for DNS services, and broadcast addresses. You'll find you've lost 5 addresses already, but you should still have plenty available for you to use. The one thing you need to be careful of is when you're creating your subnets, and remember you need to have at least one subnet per virtual network, is don't put all your available IP addresses into one subnet. If you do that, you can't add any subnets in future. So if you've got a virtual network with, say, 250 usable IP addresses and they all go into a single subnet, you can't add a second subnet later on. All those addresses are used. So allow for future growth, allow for using multiple subnets. Even if you don't need them all today, over time, you might find actually this would be better placed in a new subnet on the same VNet perhaps, but in a separate virtual network. And what these are, they're just divisions within that virtual network. They allow you to segregate traffic from each other because they're on a slightly different address range. And then, as we'll see later on, we can use things like network security groups to filter traffic between those subnets. And again, these can't overlap. You can't have the same address space in two subnets in the one VNet. They need to be unique. So the reason you might do this is something called an N-tier architecture. So if we're looking at a single virtual network, this is really a fairly good starting point for designing where an application will go. You will create multiple segments within that virtual network for different tiers of your solution design. So you might have a web tier, you might have a front-end web server where the traffic comes in. You might have a middle layer or a business tier after that, and you might have a data tier on the other side. So that might be where your databases go. And by putting those on separate subnets, again, you can isolate the traffic. So you could say, well, I'm going to allow public access from the internet into my web tier, so it's a public-facing portal, but I don't want to allow public internet traffic into my data tier where my databases are. There's no reason for that to be allowed. So you can block that from happening. And you could say, well, actually, I will allow the web tier to talk to the middle layer, the business tier, and I'll allow the business tier to talk to the data tier, but nothing else. So again, you can see how you can control the flow of traffic and how to filter traffic that way. So this is a really good starting point for an infrastructure as a service design, starting off with a single virtual network. This is still commonly used today for very small web application architectures, and this would be a very traditional approach for on-premises, where you would design a solution by using like DMZs on your network to isolate traffic from each other. This can be done very, very easily on Azure. What we're seeing more often nowadays is the use of multiple virtual networks. Okay, so there's no real extra issue with this or cost with this, or even complexity, because when you create virtual networks, they're all isolated from each other by default. Okay, by default, a single virtual network, there's no isolation. Everything within that VNet can talk to each other. Yes, you can introduce segmentation with subnets, and you can block traffic by filtering it with NSGs, but virtual networks by default are always isolated from each other unless you connect them. By using multiple virtual networks, you get more granular security and more granular routing control over the traffic on those. This is also more scalable. So every time you've got a new workload to introduce, you can just create a new virtual network, put it there in isolation, and if that needs to talk to various other systems, you can connect those. Rather than connecting everything up to each other, you can just pick and choose how you want to connect your virtual networks and how you want that traffic to route. And also, don't forget, you've got the regional distribution of VNets. They are deployed per region. So if you've got a multinational business where you've got offices in different parts of the world, you can deploy virtual networks in different Azure regions across different data centers in the world, and then pick and choose how those are connected. So we've got a few different network topology types in terms of how you design your solution with multiple networks. By far the most common approach and most widely used one is hub and spoke, which we're going to focus on today. And this is where you've got a single hub network in the center, if you like, of your deployments, and you've got various spoke networks connected off that in different locations. And again, those spoke networks could be in different Azure regions. They don't necessarily have to be all in the one region. They can be all different parts of the world, but they're all connected to one central hub network, which is usually where you put all your security services. We've also got a mesh network, which is this one here. This is where you literally connect every VNet to every other VNet. So it's connected to every single other virtual network. They're all connected to each other, so they can all speak to each other. For smaller setups, this can be ideal, but as you grow in size, this starts to become very, very complex, very difficult to maintain. We've got a new option we're not really going to cover today, something called direct connectivity. So there's a fairly new service called Azure Virtual Network Manager that's getting lots of new features lately. And this is used to, I suppose, manage your overall virtual network setups, how those networks are managed and maintained. And with that, you can actually enable a feature to allow virtual networks to speak to each other directly without actually being peered to one another. We won't cover that today, but just be aware there is that third option that's relatively new to be aware of. I'm going to focus on this one, hub and spoke, as I said, by far the most widely used approach we would see. As mentioned, you can have those spoke networks in multiple regions. They are isolated by default unless you decide to connect them together. The purpose of the hub network is really for centralized routing and security services. Okay, so that's really where you put your Azure firewall or your network virtual appliance. If you're connecting your hub network up to maybe other clouds or on-premises environments, you might put a VPN gateway in there, so you can have a VPN tunnel that only needs to go into the hub network. You don't need to have VPN gateways in each of your spokes. You only need it in that central location. So it allows everything to flow through that central hub network, which is much more efficient in terms of cost and complexity as well. It just means the routing all routes through that central hub network. So by far the most widely adopted approach is hub and spoke. I mentioned about connecting virtual networks. There's really two ways to do this. You could create a VPN tunnel between two virtual networks. Nowadays, there's really very little benefit to doing that. VNet peering is by far the preferred option. So VNet peering allows you to connect two virtual networks by using the Microsoft network backbone. So you're not losing any performance on this at all. It's as if they're all on the same VNet. Assuming they're in the same region, it's as if everything's on the one VNet in terms of performance. The fact you're using two virtual networks, you don't lose any performance. It's all connected over the Microsoft backbone network. So performance isn't affected, and it's very easy just to connect two networks together. It's a very simple process to do that. There are two types of peering. There's regional and global. The only difference is regional peering just means that those two networks that are connected are in the same Azure region. Global peering, they're two different regions. So as I mentioned, maybe a US region and a European region. The process for doing it is actually exactly the same. Okay, it's just a terminology thing. One thing to note, you can connect virtual networks that are hosted in different subscriptions or even in different tenants. So maybe if you have a company with a virtual network that needs to connect to another organization's virtual network that's in a completely different Microsoft tenant, that is possible as well. You can actually do that nowadays, which is a really great option if you need to do it. An important thing to note, VNet peering is not transitive. So what that means is if you've got three virtual networks connected together, so let's just take this VNet 1, 2, and 3. If VNet 1 is connected to VNet 2, and VNet 3 is also connected to VNet 2, VNet 1 cannot talk directly to VNet 3. It doesn't have transitive routing through VNet 2. You can achieve it with some kind of a router service in VNet 2, such as a firewall. So if you've got a firewall service in VNet 2, you could send the traffic into that, and that can then forward it on to VNet 3. But without that service, you would have to peer everything directly to each other, that mesh network I spoke about earlier on. So just something that's important to know. If you are planning to do something like this, you will need a service in that home network that can do that routing for you between VNets. And that moves us on nicely to routing. So routing controls how the traffic flows through your virtual networks. It's mostly managed by Azure for you. So the good news is you don't necessarily need to know a huge amount about routing. Azure will take care of a lot of that for you. And it applies this at the subnet level through route tables. So network interface cards, or NICs, they're used by the network resources to utilize those routes. So when you create a virtual machine, you'll see it creates a NIC for you, which is its network card. If you're creating a private endpoint for any PaaS services, that will also create a NIC. And that's where the routing happens through that network interface. Routes can be propagated from connected networks. So if you are connecting your Azure environment to, say, an on-premises network, you can propagate the routes from your on-premises networks into Azure. So it knows where those routes are, it knows where to send the traffic if it needs to go to on-premises. And again, a lot of this can happen automatically for you. But you always have the option to override the system routes that Azure gives you. So Azure will try and do the routing for you. Quite often it's fine, you don't need to do anything, but sometimes you need to say, well, actually, I need traffic going to here to go here first. So you can control that yourself. You've always got the option to override how that works. So we've got different types of routes in Azure. System routes, those are the routes Azure creates for you. As I said, these are all done kind of under the covers for you. When you peer networks together, it will automatically put in the routes for those networks so they know where to send traffic to each other. It will give you default routes. So default routes are basically how Azure knows where the traffic should go by default. So I mentioned before, by default at the moment, traffic will go out to the internet. If you need traffic to go to the internet, Azure knows how to do that. It will just send it to the internet. If you need traffic to go from one network to the other, again, by default, Azure will put in a system route and it will default the traffic saying that's designed for that address space. There you go, there's your route to that network. And then you can put in your own custom routes. So you can customize this route table and say, well, actually, I need to send traffic to this particular location, and I need to go via this route, not the way you're telling me to go. So we do that by using something called user-defined routes. And in terms of routing, this is probably the most important thing to understand, how these work, what they're used for, and how to implement them. So these are used for you to override the default system routes that Azure provides for you. So here is the diagram of a route table that Azure has created for you automatically. And you'll see these default routes, and you'll see these user routes that have been put in as custom routes for you to override the default routes. And it invalidates those default routes that Azure creates for you. So to do this, you have to create something called a route table. It's a resource like any other Azure resource. You create a route table, and then you can just specify the destinations. You can put in an IP address range prefix. That can be an Azure address range, it could be an on-premises address range, or it could be something that's on the internet. And you can tell Azure then what the next hop for that should be. Should it go directly out to the internet? Should it go to a VPN gateway and send it back to on-premises? Should it stay within the virtual network? You can also drop the traffic. You can say, if it's going to this address, just dump it. Don't send it anywhere. Or the most common one is send it to a virtual appliance. So virtual appliance is basically a firewall. It might be an Azure firewall or a network virtual appliance. And that's usually why we'll use default or user-defined routes. It's to say, no, don't send this traffic for the internet straight to the internet. Send it to a virtual appliance first of all, which is your firewall. I want to firewall this traffic first and then send it to the internet. So how does Azure know how to select a route? Well, again, it'll do its best to try and do this automatically for you using system routes, but sometimes there's conflicts. Sometimes you might have put in a user route and it might conflict with an existing system route that Azure has created for you. So when that happens, Azure uses something called the longest prefix match. And this is where two routes overlap. They're both within the same address space. What wins here is the one that has the longer prefix. So just a very simple example here. We've got two routes, route A and route B, and they're both going to this 10.0.0.0 address range, but one is using a /16 prefix and one is using a /24 prefix. Okay, so those actually overlap to each other. So if you're sending a packet then to say 10.0.0.4, which matches both of these, it's in both of these address ranges, Azure will say, well, route B has a longer prefix. This number here is bigger. 24 is a longer address prefix than this one. So that's the route I'll choose. So I'll send the traffic there rather than to the other one. So that's an important thing to note. If you're ever having issues with routing, you need to choose the longest address prefix, or you need to make sure if the traffic is not going where you want it to, make sure that there isn't a longer address prefix in that route table, because that's the one that will be picked. Fortunately, there are some useful tools that will help you to identify when that happens. And where you've got multiple routes of different types in place, user-defined routes always win. So the routes you put in and you create are always the ones that will win over any system routes. After that, it's BGP routes. These are propagated routes that have come in from connected networks. And then finally, after that, in priority, it's the system routes that Azure creates for you. But the good news is the number one priority is always user-defined routes, which means you're always in control. You can always tell Azure, no, I don't want the traffic to go where you've decided it goes. I want it to go here where I want it to go. So your user-defined routes will always win once the address prefix matches. The two main reasons that you will use user-defined routes are, number one, to send traffic through a virtual appliance. So again, if you look at this diagram, you'll see a hub network in the middle here with a virtual appliance or firewall. You would probably want to send traffic through that before it goes anywhere else, before it goes to on-premises, before it goes to another cloud, before it goes to the internet, maybe even all of your east-west traffic within Azure. Maybe you don't want to send it directly to another VM within Azure. You might want all of your traffic to be firewalled before it goes somewhere else. And to do that, you will need to override the system routes and tell Azure, no, send all the traffic to the firewall first of all, and then that will forward it on to its correct location. The other common scenario is forced tunneling, where you might want to send all of your traffic or a lot of your traffic to an on-premises location first of all. So again, rather than Azure sending it directly out to the internet, maybe you've got an on-premises firewall that needs to filter that traffic. For compliance reasons, some organizations need this. Maybe everything has to be logged centrally through an on-premises firewall, so you might need to send the traffic back to on-premises first before it breaks out to the internet. Personally, it's not something I like, just slows everything down, but again, I've seen it many times, usually for compliance reasons. It's just a requirement for some organizations to do that. One thing to note, I mentioned by default, your traffic will go out to the internet by default. That is right now. It's always been there in Azure, so when you deploy a virtual machine, that will have NAT access directly out to the internet by default. That's something called default outbound access. Okay, and that works because even if you don't put an IP address, a public IP address directly on your Azure virtual machine, Azure will create one for you. It will create an implicit public IP address. You don't see it, it's not a resource, it's kind of hidden away, but that allows that virtual machine to access the internet without you doing anything else. From the end of September 2025, for any new deployments, any new virtual machines you create after that time, that's no longer going to work. So Microsoft are making a change here. That default outbound access is going away. So just for security reasons, you're going to have an explicit way for that machine to get out to the internet. Okay, so you're going to need to put a route out to the internet for any machines after that date. And there's really four options here. One is you put in a firewall or a virtual appliance, route the traffic out through that appliance. It uses the public IP address of that firewall or virtual appliance to break out to the internet. And that's the best practice. There's three other options. NAT gateway, which is it's a really simple approach to set up, and that's covered at the next slide. That gives you an option to route traffic out through an appliance called a NAT gateway. That's for outbound traffic only. It uses the IP address of the NAT gateway. You could also do the same thing with an Azure load balancer. Don't really see too many use cases for this. NAT gateway would be a better option. And the last option is you could actually just put a public IP address directly on the Azure VM. And that's okay if you've maybe only got one VM, but if you've got 10 VMs that all need internet access, you don't want 10 IP addresses, one for each VM. It just becomes very difficult to manage that at scale. So by far, if you're not doing the firewall option, I would say the best option is the NAT gateway. It's the one Microsoft recommend. As I mentioned, this is just another service you can deploy very, very quickly. All you need to do is create the service, create an IP address or arrange an IP prefix of addresses, and then you need to assign that to any subnets of the virtual network that you want to apply it to. So what happens then is any traffic that's going outbound will just route out through this service. It doesn't allow any inbound traffic at all. It just allows outbound NAT to the internet. Great example of this is if you've got, say, something like an Azure virtual desktop environment, and you might need to whitelist some IP addresses. Maybe your users are accessing some service that needs a fixed IP address that's been whitelisted. At the moment, if you don't have any IP addresses, if you're just using that implicit NAT route, those addresses can change very frequently. But if you route the traffic through this service, an Azure Virtual Network NAT, it will use the IP address of that. So it's very easy to just whitelist the IP address of this service. And this is great. It's not a free service, but it's a relatively low cost service. So I would say do the firewall if you can. It's obviously a more expensive option, but it's the best option from a security point of view. Failing that, this would be my recommendation for doing outbound internet access. So just be aware of that change that's coming in September of next year. Right, so let's talk a little bit about VPN connectivity. What's this all about? Well, primarily it's used to connect your Azure virtual networks to other networks, quite often on premises, but those networks might be in other cloud environments as well. The traffic is encrypted and sent over the public internet. So do remember, it is going through the public internet, but it is encrypted in transit before it's actually sent out. There's a few ways you can do this. You can do this with network appliances, virtual network appliances in Azure, but the most common approach is to use a service called an Azure Virtual Network Gateway or a VPN gateway in Azure. And that's all that service is used for. It's not a firewall service. It's literally just used for a VPN tunnel. You will get two connection types with this. You will get a site-to-site connection from that VPN gateway, and that allows you to create a permanent connection between the VPN gateway in Azure to that on-premises network. And that's really to have that entire network connected. So if you've got an on-prem network and you want to connect that up to your Azure virtual network, That's where you use a site-to-site tunnel. It means any users on that network can access the Azure network. You can still control it with things like network security groups, which machines can access which other machines and subnets and so on. So you do have control over it. But effectively, you are connecting those two networks together and forming one big network with a site-to-site connection. The other option then is a point-to-site connection, and this is really used. This is a device-level user VPN. So where you've got remote workers who are working from home, and they're not going to have a permanent site connection into Azure. They just want to connect their device to Azure from home. This is a VPN client connection into that Azure VPN gateway. And you can do both of these at the same time with a single VPN gateway in Azure. You get both connections included. So site-to-site, first of all, what's needed for this? Again, plan this carefully. Look at your address spaces. Remember, you don't want to overlap those. If necessary, if you're stuck, you can do it with certain SKUs of the VPN gateway. You can NAT over a VPN, and if you have the same address space. But ideally, if you've got the choice, make sure you don't overlap address spaces. Just makes life much easier for you. So on the Azure side of things, you've obviously going to have your VNets and subnets defined. We won't cover DNS today, but that is an important consideration for your DNS setup. You will need to create a separate gateway for the VPN gateway. I'll cover that in the next slide. That needs its own dedicated subnet. So again, remember when you're designing your virtual networks, don't put all your address space into one subnet, because if you need to add a VPN gateway, you will need to create a new subnet for that. And if you've got no free address spaces left, you just won't be able to do that. So just be careful with that. Then you create the VPN gateway itself. After that, you will need to connect to a site. So you'll need something called a local network gateway, and that's really just all the settings you need for your on-premises connection. So it's your on-prem public IP address, local address space, and a shared key to connect to that site. You'll need to configure your on-premises VPN device. So that's usually a firewall appliance on-premises that you're going to actually connect to. That needs to be configured to talk to the VPN gateway in Azure. And then the last step is to create that actual connection itself to connect those two appliances up. So again, planning this out, be careful. This does need a dedicated address space. It needs to have needs to be called a certain name. In terms of size, it doesn't need to be a very big size, but again, you need to just want to make sure it's big enough to hold it. So this VPN gateway, while it allows you to connect your on-premises site to Azure, you can actually use it to connect two VNets to each other as well. Again, as I mentioned, not commonly required anymore, but just be aware you can connect two VNets to each other using a VPN gateway as well. In terms of the subnet itself, it should be either a /28 or /27. If you're using that hub and spoke model I spoke about, put it in the hub VNet. That's the best place for it because it's central to everything. You only need one VPN gateway that goes in the hub network. What happens when you deploy the VPN gateway then is under the hood, Microsoft will actually deploy two virtual machines that you won't see, you won't have access to, but they're effectively two VPN gateways. So you've got high availability there. You've got two virtual machines running as your VPN gateway hosted on that subnet. That's why you need address spaces because those machines will need IP addresses. They're deployed there. You do not want to deploy anything else in that subnet, so please don't put any other VPNs in that subnet because you'll run into routing issues where you won't be able to send traffic to those machines. So just keep that subnet dedicated just for the VPN gateway itself. When you're configuring the VPN gateway, you have loads of different options here. There's the SKU of the gateway itself. You've got a basic SKU, which is limited to, I think, a max of 100 megabits per second and has very limited features. And then you've got standard SKU, which scale up in size in terms of the amount of bandwidth and the amount of connections they support. You also have the option of deploying these into availability zones. So remember I mentioned you get two machines, two VPN gateways. If you want to, you can distribute those VPN gateway machines into different availability zones if they're available in your Azure region. And again, that's just to make the solution a bit more resilient for you. You will need to associate that with the gateway subnet. So obviously, this can only go into a gateway subnet, a dedicated subnet on your VNet. You cannot put these machines anywhere else other than that. And it will need a public IP address. So in order for you To connect other sites to this, it needs to have a public IP address. This service does take about 45 minutes to deploy. So if you are provisioning this as part of maybe a disaster recovery strategy, I would say build this ahead. Make sure this is built, up and running and tested and permanently available, because the last thing you want to do is build this when you're in a panic and you need to get this up as soon as possible. This is not one of the services you can turn off and on as needed. You're charged basically by the hour for it, or by the minute, I think. The only way to turn it off is to delete it, but then to recreate it, you're looking at another 45 minutes to spin it up. So this should be deployed even if you're not planning to use it straight away. If it's just a DOR strategy, get it configured and tested and working, so you don't have to do it in a hurry. As I mentioned, after the gateway is deployed, you need a local network gateway. This is the on-premises configuration. So you'll see very simply, you need to put in the public IP address that's attached to your on-premises firewall or whatever you're using. You'll need to put in the local address space of your on-premises network. So again, ideally, you don't want that to be overlapping with your Azure virtual network. And if you're doing any BGP or any other kind of routing, you can configure that at this stage as well. You will need to configure your on-premises VPN appliance. So again, this is just configuring your on-premises firewall to match the settings in Azure. There's loads of how-to guides for this. Most devices are supported nowadays. There are some scripts there as well to help you with this. Of some appliances, you can actually download a script to help you configure that appliance. But what I found over the years is if you just go onto your vendor's website, they'll probably have a KD article there documented how to configure this to talk to an Azure VPN gateway, and it does support most of the various VPN encryption types and encapsulation types that are available. So nowadays, the vast majority of third-party appliances will support this. It's very unusual to find a case where you can't connect to this because your device is unsupported. There's a good support for this. The last step in it is the actual connection itself. So this is really just saying, I want this VPN gateway and this local network gateway to connect and talk to each other, and they're just configured in this connection step. So you'll need to enter a pre-shared key here. This needs to match your on-premises device's pre-shared key, and that's just like a password or a secret, so they can talk to each other. Just to cover off then point-to-site networks as well. So point-to-site is included with the same VPN gateway. There's different protocols supported here. You've got OpenVPN protocol, you've got secure socket tunneling, and you've got IKV2. So OpenVPN is becoming a very popular methodology for connecting devices to Azure. The main reason is that supports Entra authentication. So traditionally with point-to-site, you had to use Azure certificates, and you needed a certificate generated and installed on every device that connected into Azure. As you can imagine, at scale, that's very difficult to maintain. You can use Active Directory, traditional Active Directory domain services authentication, but to do that, you will need a Radius server as well. So there's a bit of work required to do this. If you've got that infrastructure in place, that's a good option, but I really like using the Entra authentication option nowadays as well. So that means if you've got Entra IDs, you can leverage those IDs to connect, and you can use things like conditional access policies to enforce MFA or trusted devices or trusted locations as well. So it's a really great option, but just note that uses the OpenVPN protocol. So when you're deploying your point-to-site, make sure you choose OpenVPN to use that. Same again, it's just quite easy to set this up in terms of configuration. It's in the same VPN gateway. You just go into the point-to-site configuration section. You will have to define an address space for your VPN client users. And again, this can be a completely different address space to what you've used previously, and depending on what you've chosen for authentication. So if you're choosing Entra authentication, there's a few steps to go through to set that up, but it's very well documented, and that would be the approach I would choose. Look for Entra authentication. If your organization is using that, you may as well use that same identity for your VPN clients as well. Right, on to network security. I'm a bit behind time, so I might have to speed up a little bit. This is obviously a very extensive topic in itself. Ideally, security is always a multi-layered solution. You want to add on as many different layers as possible. You want to, in terms of network security, you want to cover the network layer, the transport, and the application layers. So at the network perimeter, traditionally you would have a firewall appliance of some kind, just doing that application layer inspection. You might use something, if it's web traffic only, you could be using a WAF feature, Web Application Firewall for Azure Front Door or Application Gateway. You've got DDoS protection as well. We're protecting you from distributed denial of service attacks. That's an optional service you can add in. And then on the network or the transport layer itself, we're going to use user-defined routes, which we spoke about, that allows you to flow the traffic the way you want it to, giving you control over security and filtering, how you allow the traffic to flow through your networks. And then we've got network security groups, which is what I want to talk about here. So network security groups, or NSGs, it's a free service. This allows you to do filtering on up to layer 3 and layer 4, so up to the protocol layer of your traffic on the network. So it doesn't look at any application layer stuff at all. It's not going to do the same job as a firewall, but it will allow you to create inbound and outbound traffic rules on your network, and you will be able to then control what you can allow in and allow out in terms of addresses, ports, and protocols. It just doesn't look at anything beyond that layer. Just remember that. You can associate these with subnets, or you can associate them with NICs, individual NICs for various machines or endpoints. And they can be reused. You can associate them with multiple services as well. So in terms of what they look like, you will see you get a list of default rules out of the box, which are these kind of 65,000 series rules. And you'll note it does allow all network inbound and outbound traffic by default. Okay, so all traffic on the VNet by default is allowed to talk to each other. So remember I said if you're using subnets or if you're connecting VNets together, by default, everything can talk to each other once it's connected. If you want to restrict that, you can put in rules to say, well, actually, I don't want this to talk to that. I don't want this subnet to be able to talk to that subnet. So you do that by creating NSG rules with a higher priority than these rules. So you're basically overriding these. So these allow rules are always there. You can't turn these off, you can't delete them, but you can put in rules above these with a higher priority to say, well, actually, if it meets this criteria, don't let it happen. So you can get very specific about what you allow and what you don't allow. This is an example of a custom rule that's been created to allow remote desktop traffic inbound on port 3389. Any protocol is allowed. And here you can say, well, I've allowed any source IP address here. Now this would be a bad practice, which is why you're getting a little warning symbol here. But you could actually specify, well, actually, I only want to allow ODP traffic in from this particular public IP address. So you could really restrict where the traffic comes from in terms of source, destination, ports, and protocols. But that's as far as you can go with NSGs. Just in terms of the traffic flow itself, as mentioned, NSGs can be associated with subnets or with NICs, or you could do both. To allow traffic inbound, you will need to make sure it's allowed. If you've associated an NSG both on the subnet and the NIC, if it's inbound traffic, it will hit the subnet layer first, and then it will hit the NIC afterwards. So you will need to make sure you've allowed traffic on both of those in order for it to pass through both layers. And for outbound traffic, it's the opposite. It will hit the NSG on the NIC first of all, and then if it's allowed through that, then it will get to the one on the subnet layer. So again, it would need to be allowed on both in order for it to pass out. As a best practice, usually try to use NSGs on the subnet level only. If you need to get very granular, very specific, then put them on the NICs. But I always find if you remember that N-tier architecture, put all the same types of VMs in the same subnet, so they're all using the same NSG rules. You don't want to get too granular with them. If you've got a different set of rules for a different VM type, put that on a different subnet. Just have one NSG per subnet. All the hosts, all the NICs on that subnet then inherit those rules, and it's just the easiest way to maintain it. You can always go more granular if you want to, but in terms of just trying to manage and maintain it, it's just easier to do it that way, I find. One thing to note as well, you can use service tags, so you don't have to use IP addresses. What you could say is, well, I want to allow traffic to go to various Azure services. Maybe you want to block all traffic by default, but you need to allow access to certain Azure services. Most of those services have a tag associated with, like Azure Storage, for example. You can say, well, if it's going to Azure Storage, allow it. So you don't have to put in any Azure IP addresses, because obviously these are very vast and they can change. You can just tag the traffic and allow it that way, or block it that way if you wish. Just a very quick one on application security groups. This is just a feature you can use in tandem with NSG. So if you've got a lot of IP addresses, example I always use here is if you've got a web farm, if you've got multiple servers hosting a website, for example, and they've all got private IP addresses, and you might have 10 or 20 servers. You don't want to have to put 10 or 20 IP addresses into your rules. Instead, what you can do is you can create an application group, call it web servers or whatever you need to, and then you can associate each of those NICs for those VMs into that group. And then you can just have a single rule in your NSG, and you can just associate it with your application security group. So rather than you looking at your rules and trying to remember what all those IP addresses are for, you can say, yeah, that's the web servers, that's what they're used for. So it's just an easier way to group things together and simplify your rules. Just remember for these, if all the NICs within the same ASG must be on the same virtual network, so they can't span networks. And if you're using an ASG for both source and for destinations in the same rule, the source and the destination, again, must be on the same virtual network. So you do have a bit of a restriction there. One thing I just wanted to cover in the security space here, again, we don't have time for much more, is just Azure Bastion is a really great service. So this is used for accessing your machines for doing admin work. So if you need RDP access to Windows machines or SSH access to Linux machines, just for doing remote admin work, and you always need to do this, rather than putting public IP addresses on them and putting in NSG rules and whitelisting, Azure Bastion is a jump box that's built into Azure to do this for you. So this allows you to remote in and do this without you having to put any NSG rules in place. What's really great is there's now a new SKU of this called the developer SKU. It's completely free of charge. Now it is meant for kind of test environments and developing solutions. It does have some limitations, but at the very minimum, you should use this to allow you to have remote access to your machines. You will have to use the Azure portal to connect into your VMs with that SKU, but it's a great way to have secure access to your machines without having to mess around with opening ports or anything like that. So that's a great service for securing access to your machines, but it's really more for administrative purposes, not like for users who are accessing Azure Virtual Desktop to do their day jobs. So that's Azure Bastion. So on to connectivity troubleshooting, just to finish off then. And the idea of this section was to say, well, what happens if things stop working? If your traffic is not flowing from A to B, maybe it's a routing issue, or is something blocking the traffic, or it could be a DNS issue. We didn't cover DNS today, but usually it's DNS related. Just don't forget about that. You can't figure out what the issue is. So how can you see what is happening? What tools have you got to help you? So you need to have tools to troubleshoot, because otherwise it's extremely difficult. So we have three options here in Azure to look at. If you go into the Azure Monitor section and into the Insight section of that, into networking within that, there's actually some good useful network insights in here. So you can look at the network health and metrics here of your networks. So it'll tell you if there's any issues with those networks, and give you some kind of general metrics of what's happening there. And that's okay, but it doesn't really help you too much with troubleshooting. But you've got a connectivity section here, and you can actually set up connection monitors between your networks, or between your network and your on-premise network. And that can be a constant thing that's constantly just doing like a ping just to see, can the network traffic flow? And if not, it will trigger an alert. But you can see that very quickly here in the connectivity section. You can set up flow logs to monitor the flow of your traffic through your networks, and you can view that in here. And there's also a diagnostic toolkit in here, and that's really just a link to some tools that I'm going to show you in a moment. So those tools you'll find here under Network Watcher. Just something not well known about. If you just go into the Azure portal and type Network Watcher, have a look at this. There's some really useful tools in here to help you troubleshooting your networks. You've got a network topology option here. This will give you basically a diagram of your virtual networks and how they're all connected to help you visualize that. You've got IP flow verify, which will help you verify the flow between one IP address and another. You've got next hop. That's the one that you use for routing issues. So if you are routing your traffic through a firewall and you're finding it doesn't seem to be getting there, you can check, well, actually, is it following the correct route? I put in a user-defined route, but is it actually using that route? So that tool will tell you, yes, it is sending the traffic to the firewall, or no, it's not. You've got VPN diagnostics that will help you troubleshoot VPN issues. You've got VNet flow logs, which I'll cover in the next slide. That's a fairly new service that allows you to really trace the flow of traffic through your virtual network. And you've got a connection troubleshooter tool that will help you really troubleshoot connections between, again, one IP address on a VM and another one. So just one thing to note here with these tools, unfortunately, a lot of these tools do require a running virtual machine on the subnet you're trying to troubleshoot. And the reason for that is it needs to install an agent on that machine that will actually test the flow of the traffic. So it's a bit unfortunate, but again, it's a small price to pay to figure out why your traffic isn't flowing as you'd expect. So just something to be aware of. So finally, just VNet flow logs. This is quite a new service. This is going to replace something that's been around for a while called NSG flow logs, which really only operates on the NSG layer. You would need to have NSGs in place and allow the traffic to flow through those. With this, you can turn it on, you can enroll your virtual networks. It logs all the traffic flowing through those virtual networks. So you can really see all the ingress and egress traffic on your networks and do proper traces. See, well, actually, where is my traffic stopping? How far is it getting before it seems to disappear? So these logs are generated in a JSON format. You can then download them and use like a tool such as Kibana, or there's some Power BI plugins you can use just to help you visualize those tools later on. That's me. I ran a bit longer than I expected, but I think we have a few minutes left for Q&A. I think there are a few questions in, so I can take those now.
Thank you, Alan, for a great presentation. So we'll now get into the questions and answers part. Should you wish to ask a question, please feel free to type it in the questions box now. So our first question is, in terms of inbound, outbound traffic access control list, can you please detail how network security groups, Azure Research Group, network rules, and application firewalls, NATs, work with them? Do each of them have ACL? Which one of them are stateless or stateful?
That is a very complex question. It sounds like multiple questions in one. Do I have access to these? I'm just trying to see if I can read that myself.
No, I don't think you'll be able to see them.
Oh, I can
if you want me to read it out again?
Yeah, if you could quickly, yeah, I'll try and cover it.
In terms of inbound, outbound traffic access control list, can you please detail how network security groups, Azure Research Group network rules, and application firewalls, NATs, work with them? Do each of them have ACL? Which one of them are stateless or stateful?
Okay. Yeah, so there are various ways to do this, and yes, you can kind of double up if you're using firewalls, which again you don't have to. It's good practice. You would have your normal access rules in there to allow traffic in and out. You can do the same on NSGs. Some say, there's no point. You're kind of doubling up, but it's good practice, because if maybe you make a mistake on a firewall, at least maybe the NSG will catch you. The difference is your firewall is actually doing application layer inspection as well. So yeah, you would set them up on both, ideally. In terms of statefulness, generally it should work. It depends what you're using. If you're using Azure Firewall, it should handle the state for you. NSG doesn't change anything. It doesn't do anything. If you're using it, it's going through another appliance like a network virtual appliance or an Azure Firewall that obviously has an IP address, and it's doing translation for you. So depending on rule types, I mean, there's different. We're talking specifically about Azure Firewall. You've got application rules and you've got network rules. And I think it's the network rules will do the source mapping for you, and the application rules don't. So it's quite a vast subject to go into, but generally speaking, it's handled for you by that appliance. You don't have to worry about it, but it really depends specifically what way you set it up. There's just so many different ways you can do this. Yeah, so there's no kind of one answer. There's no kind of single answer to that one, unfortunately.
Perfect, Alan. Just the next question there is, when one application send requests through the NSG outbound allow traffic to HTTP, it would expect reply without configuring HTTP inbound access. Would the application be able to receive the response?
Yeah, it's stateful in that respect. So if you've allowed outbound access, so if you're HTTPS, if you've allowed internet access outbound, it's stateful. It'll go out and come back in on that same connection. So it doesn't It's not going to allow a new connection on port 443 for HTTPS to come in, but if you've allowed a connection out, that connection can talk inbound and outbound, and you can initiate it. But yeah, it doesn't. If you wanted to allow a separate inbound connection, you would have to put in an allow rule on the inbound connections for that. But in terms of outbound, that is stateful. Yeah.
Perfect. So I think the next question is, how do you see the role of AI and machine learning evolving in the context of network management in Azure?
Yeah, that'll be an interesting one. And I'd say we'll see it in Azure Virtual Network Manager, which is that new, relatively new service I mentioned. I'd say Microsoft might bring something into that. So they've added some features, not AI features, but they've added some features to allow security groups and routing to be set up in that for you. How will it help? I'd say more, initially, I'd say more as yet another co-pilot. There is an Azure Copilot already. It's not great from my experience, but I'd say initially what we'll see is you'll be able to ask the Copilot, I need to set up this configuration. I need traffic to route from this to this. You have to ask a question and it will tell you, okay, well, here's what you need to do. You can already do that with Microsoft Copilot and ChatGPT and so on. So initially, I think that's all it'll be. It'll just be to help you to design your architecture, and it'll give you kind of hints on what you need to do rather than actually do it for you. After that, what I would like to see is if it can analyze VNet flow logs. You can say, I've turned on VNet flow logs. Here are the logs. I need to troubleshoot this, and you need to tell it you basically tell it to analyze the logs and say, look, this IP address is not getting to this destination. Can you help me to troubleshoot? So I'd say something like that, which might be doable now with a bit of work, but something like that that's more built into the Azure portal would be really cool. After that, I don't know. You're probably getting into more kind of security related stuff, that kind of architecture and designs. But I think to help troubleshoot routing issues would be great if it can help with that, take some of the manual effort and expertise off that to say, well, I can do that for you, because it is difficult to read through log files, especially in JSON format, and find the problem. So machines can do that a lot better than humans can. So that would be something I think would be something to look out for. Should be doable.
Perfect. Yeah, so I think that's all the questions. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Alan, for taking time out today to carry out this webinar. Really appreciate it.
No problem at all, my pleasure.
So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you for joining us today, and I hope you join us again soon. Take care.